Every year, millions of tons of plastic waste enters our oceans. Among the most harmful are discarded fishing nets, strong enough to withstand the pressure of open water, yet nearly impossible for nature to break down. At Circular Solutions, we wanted to rethink this material. Instead of seeing waste, we asked, what can these nets become? This design sprint became the story of turning a problem into potential. Our journey begins with recovery. Each net is salvaged from the waters surrounding the Galápagos Islands and sent to us through Helen of the Sea, a startup committed to protecting marine ecosystems. These nets are made of polypropylene, a tough, lightweight, and highly recyclable thermoplastic. In our project, polypropylene isn't just raw waste. It's the foundation of our biomaterial solution. Once cleaned, the nets are shredded into small, consistent flakes. This creates a uniform feedstock, essential for heating, melting, and transforming the material with precision. The flakes are heated to over 200 degrees Celsius. At this stage, the plastic becomes a viscous, workable liquid, no longer a discarded net, but a material with new possibilities. From this liquid state, we extrude the material into recycled filament. This filament is our circular material solution, a renewable input that can be used for countless 3D printed products. Each strand represents the first transformation, from ocean pollution to high-value biomaterial. To demonstrate its potential, we needed a real application. We chose to create a surf comb, an essential tool for waxing and maintaining surfboards, a product that stays close to the ocean it helps protect. In SolidWorks, we optimized the comb's fish-inspired geometry for smooth printing, ergonomic comfort, and durability under repeated use. This design wasn't chosen by accident. The fish shape symbolizes its origins, honoring the marine life affected by ghost nets while reminding us of the circular story it carries. Every printed layer shows how a simple filament can become a purposeful object. By 3D printing with regular filament, we were able to get the right dimensions. We collaborated with another enterprise team called Board Sports to test our prototype and get the right feedback from real surfers. The finished comb is a lightweight, durable, and entirely made from recycled material. Proof that functional products can grow out of reclaimed waste streams. More than an object, it's a narrative you can hold, a reminder that waste is only waste when we fail to imagine alternatives. This sprint pushed us to rethink materials, systems, and design. By creating a closed loop, collect, process, extrude, print, Circular Solutions demonstrates a model where materials stay in use longer and value is continually regenerated. The surf comb is just the beginning. Our polypropylene filament can be used to create a wide range of ocean-oriented products, tools, accessories, and components that extend the life of recovered fishing nets. At Circular Solutions, we believe sustainability is not an endpoint, it's a cycle. By transforming ocean plastics into practical products, we're designing more than tools. We're designing change. Join us in turning waste into waves of innovation. In the fall, we took our vision, the Ghost Comb, to the Biodesign Sprint, proving that waste doesn't have to be the end of the road. During the international competition, we introduced our team to the world while presenting many different aspects of the surf comb. We were able to clearly communicate the problem we were looking to solve: ocean pollution. This transitioned into our project focus, the solution, turning polypropylene fishing nets into 3D filament. Then we got into how we created the filament and tested a variety of temperatures to see which would produce the best filament. From there, we talked about the challenges we faced throughout the process, such as UV and salt degradation, the filament breaking after a few inches of extrusion, and using a mix of virgin and recycled polypropylene to melt the material more consistently. We intended our Ghost Comb to be a hit in the surf community through market research. Our process aligned with the surfers' deep value for environmental consciousness while also being known for high consumption and frequent travel. We also ran a SWOT analysis with the conclusion that there is a strong case for targeting this market niche because there is expanding regulatory pressure on disposable plastic products, increasing awareness of plastic pollution, and a strong cultural incentive for recycled surf gear. Our product design development comes from many different areas: the functionality, visual, and design choices. By using SolidWorks CAD software and a Creality 3D printer, we were able to make this vision come to life using PLA filament in the testing process. To test our 3D printed prototypes, we collaborated with Board Sports Enterprise for surfer feedback. The product life cycle of the comb led us to the conclusion that our combs are designed to be reprocessed into new recycled plastic products to reduce virgin plastic demand and prevent future pollution. Scalability is central to growing the impact of the surf comb and expanding other applications of our filament. We presented how we would launch in core surf communities already engaged in the pollution reduction. By presenting our ethical considerations, we showed that sourcing fish nets to protect marine ecosystems while avoiding any additional harm. We ended our presentation on the conclusion that balancing sustainability with cost ensures our solutions remain both environmentally responsible and widely accessible. After answering some tough questions from the Sprint design judges, we were awarded gold medal recognition in narrative, concept, and reflection. The judges appreciated the practicality and down-to-earth qualities of our project, along with our social critique of surf culture around lifestyle and the detail on our design iteration and engineering. Beyond the award itself, the Biodesign Sprint was an incredibly rewarding experience that allowed us to learn new skills, work through real engineering challenges, and present our ideas in a competitive setting. Building off the fall semester, for the spring we split into two specialized branches, with one team taking on maple veneer skateboard scraps from Quincy Manufacturing to make pickleball paddles, while the other team developed research for an ongoing biogas digester project with Ghost House Farm.